Welcome to 2.3 Angle Relationships with Parallel Lines. First off, a transversal is a line that connects two or more other distinct lines. There are 8 angles formed by a transversal with 2 lines. So here are M and M are our parallel lines, and then T is the transversal, creating 8 angles. The more parallel lines, or the more lines a transversal goes through, the more angle pairs you will create. First off, 3, 4, 5, and 6, those angles are inside, so they're called interior angles. 1, 2, 7, and 8 are outside, they're called exterior angles. Angles 1, 2, 3, and 4 are in an angle group, and then 5, 6, and 7 are in a different angle group. And we're going to use those terms a lot when we're going to help you remember these. We're going to create a foldable. We do have a guided note prepared, but if not, you can make this in a notebook piece of paper. So our angle pairs, the first one is an alternate interior angle. It is non-adjacent, meaning not touching. It's interior angles, and they lie on opposite sides of the transversal. So the way to remember this is opposite side, different group. So first off, our interiors are 3, 4, 5, and 6. Our alternate interiors are 3 and 6, 4 and 5. Okay, so 3 and 6 are the same, they're alternate interiors. 4 and 5 are a different pair of alternate interiors. Our theorem that goes with this, if parallel lines are cut by a transversal, then alternate interior angles are congruent. Okay, so alternate interiors are congruent. We have consecutive interiors. They're on the same side this time. So same side, different group. Here it's 3 and 5, 4 and 6. And our theorem for this, they are not congruent, but they are supplementary. So if they're parallel lines, then the same side interiors or consecutive interiors are supplementary. So they add up to 180. The next one is alternate exterior angles. These are similar to alternate interior, except these are exterior. Opposite sides, different group. So angle 1 and angle 8, angle 2 and angle 7 are pairs of alternate exterior. Just like alternate interior, alternate exterior angles are congruent. The next one's corresponding angles. They lie on the same side of the transversal in corresponding position, which means in the same position. So they're in same position, different group. So top left, angle 1 and angle 5. Top right, angle 2 and angle 6. Bottom left, 3 and 7. Bottom right is 4 and 8. So those are examples. Go ahead and color those in to match them. Okay, and corresponding angles are congruent. Our next set is vertical angles. We already know these, but there are 2 angles whose sides form pairs of opposite rays. They still appear, but this time they're in the same group and they're not adjacent. So 1 and 4, 2 and 3, 5 and 8, 6 and 7. There are 4 pairs created by the transversal and the lines. Okay, vertical angles are congruent, as we already know. The last set is linear pair. There are 2 adjacent angles who form straight line, same group, they're adjacent. So this is 1 and 2, 1 and 3, 2 and 4, 3 and 4, 5 and 6, 5 and 7, 6 and 8, 7 and 8. Each angle has a 2 different pair. Okay, linear pairs are supplementary, so they add up to 180. So 1 and 2, also realize that it could be sideways, 5 and 7. Okay, they add up to 180. A couple examples how we do this. If angle 1 is 120, we can find the rest of our angle measurements. Well, angle 1 and angle 4 are vertical, so angle 4 is 120. Angle 1 and angle 5 are corresponding, so they're also 120. And then angle 1 and angle 8 are alternate exteriors, so they're 180. But the idea is that if angle 1 is 120, then all obtuse angles here are 120. So that's 1, 4, 5, and 8. All right, angle 2 is supplementary with angle 1 because they form a linear pair, so we do 180 minus 120, we get angle 60. And that means all of the acute angles are then 60. So angle 3 being vertical with angle 2, Angle 6 is alternate interior to angle 3, so it's also 60, and then angle 7 is vertical to angle 6, so it's also 60. Okay, so that is a quick numerical example. The converses are also true, so we can reverse the theorem. The corresponding angle converse is that if corresponding angles are congruent, then the lines are parallel. Alternate interior angles are congruent, then the lines are parallel. Same side interior or consecutive interior angles converse. If consecutive interiors are supplementary, then the lines are parallel. And the last one is alternate exterior angles. If the alternate exterior angles are congruent, then the lines are parallel. So the idea of the converse is the converse goes backwards. If we know that they're congruent or supplementary, then we can say lines are parallel. The original way is if the lines are parallel, then they're congruent or supplementary. Linear pair and vertical does not work for this because they are in the same group. For example here, is this enough information? Well, we know if the top angle is 75 and the bottom angle there is 105, we can then find the supplementary angle. Our other exterior angle on the bottom is 75 because 180 minus 105. And alternate exterior angles would therefore be congruent. So this is enough information because we have supplementary angles here. Okay, so that's 75. And here we could use corresponding angles. We also use alternate exterior if we would like. Can we prove that A is parallel to B here? Yes, we can. This is by the alternate exterior angle theorem, or converse. And B, we cannot, because angle 1 and angle 2 are supplementary instead of congruent, and this is alternate exterior, or alternate interior, and so that wouldn't work. So no, supplementary angles don't have to be congruent. So what's the difference between what you can prove with corresponding angles converse and corresponding angles postulate? The converse states that if corresponding angles are congruent, then the lines are parallel. And the postulate states that if the lines are parallel, then corresponding angles are congruent. So it's all about what you're trying to prove. Okay, that is it for the notes. Good luck on the practice and application.